Hello dear student, I am Rohini Daund. I will welcome to all of you. Today we will discuss about component of an Android application and a manifest file. In a previous lecture we have discussed about introduction to Android, then features of Android, then the Android application architecture. In the component of an Android application, first one is the Android manifest file, then the r.java resources, then the assets, activity, layouts, reference to the resources in a XML file, configuration change and the context. First one is the Android manifest.xml. The component and the setting of an Android application are described in the Android manifest.xml file. For example, all activities and services of the application must be declared in this file. It must also contain the required permission for the application. Every project in the Android includes a manifest file and which is Android manifest.xml, which is stored in the root directory of its project hierarchy. The manifest file is an important part of our application because it defines the structure and metadata of our application, its components and its requirements. And also this file includes nodes for each of the activities, services, content providers and the broadcast receiver that make the application and using intent filter and permissions determine how they coordinate with each other and other application. The manifest file also specifies the application metadata which include its icon, version, version number, theme, etc. And additional top level nodes can specify any required permissions, unit test and define hardware screen or the platform requirement. The manifest comprises of a root manifest tag with a package attribute used within the file. We use version code attribute is used to define the current application version in the form of an integer that increments itself with the iteration of version due to updation. And also version name attribute is used to specify a public version that will be displayed to the user. A typical manifest node look as a first is the application. A manifest can contain only one application node. It uses attributes to specify the metadata for your application, including its title, icon, theme. During development, we should include attribute set to true enable debugging. Then be sure to disable it for your release builds. The application node also acts as a container for the activity, service, content provider and the broadcast receiver nodes that specify the application component. The name our custom application class can be specified using the Android name attribute. Then the activity tag defines an activity. In this example, pointing to convert plus in the com.example.myApplication package. The intent filter is a register for this class which defines that this activity is started once the application start. Action Android name is equal to android.intent.action.main. Then the category Android name is equal to android.intent.category launcher defines that this application is added to the application directory on the Android device. Then the Android colon label is equal to @string slash app underscore name. Value refers to resource files which contain the actual value of the application name. The usage of resource file makes it easy to provide different resources, for example, strings, colors, icons for different devices, and make it easy to translate application. Then the usage SDK part of the Android manifest.xml file. It defines the minimal SDK version for which your application is valid. This will prevent your application being installed on unsupported devices. R.Java and resources. Android R.Java is a class that contains definition for all the resources, a specific application that you are building. Every resource that is used in your application will have its ID in the Android R.Java file. R.Java is generated class which contain the references to certain resources of the project. These resources must be defined in the res directory and can be XML files, icon or pictures. You can, for example, define values, menu, layouts or animations via XML file. If you create a new resource, the corresponding reference is automatically created in R.Java via the Eclipse edited tools, and these references are static integer value and define IDs for the resources. The Android system provides methods to access the corresponding resource via these IDs. For example, to access a string with the r.string.yourString ID, you would use the getString in a bracket r.string.yourString and you can call the method. R.Java is automatically created by the Eclipse development environment. Manual changes are not necessary and will be overridden by the tooling. In the R.Java file contain two types of the members, static final classes and static final integers. An R.Java file is generated by using AAPT, means Android Assets Packaging Tools. User is not supposed to change this. You change this, it will be erased as it is auto-generated every time. Then the resources. There are many more items which you use to build a good Android application. Apart from coding for application, you take care of various other resources like static content that your code usage such as bitmaps, colors, layout definition, user interface string, animation, instruction, and more. These resources are always maintained separately in various subdirectories under res/directory of the project. Resources are the additional files and static content that your code usage, such as bitmaps, layout definition, user interface string, animation instruction, and more. You should always externalize app resources such as images and a string from your code so that you can maintain them independently. You should also provide alternative resources for specific device configuration by grouping them in specifically named resource directories. Assets. Assets provide a way to include arbitrary files like text, XML, fonts, music, and video in your application. If you try to include these files as resources, Android will process them into its resource system and you will not be able to get the raw data. If you want to access data untouched, assets are one way to do it. Assets added to your project will show up just like a file system that can read from your application by using the asset manager. Why? The RES directory contains structure values which are known to Android platform, and the asset directory can be used to store any kind of data. You access this data via the asset manager which can access the get assets method. Next component is activities and layouts. An activity is the first stepping stone, is the building an Android user application. It provides the space to the user for doing anything and everything. For example, opening a contact, dialing a caller, etc. Everything is done by interacting with a window and that very window is provided by an activity. A window is provided to each activity where user interfacing is done. Generally, every Android application has more than one activity. There is one main activity and all other activities are child activities. This is a stack called backstack. Whenever there is a new window is started, previous activity is paused to backstack and it is stopped until the new activity is done. As soon as the back key of your device is pressed, new activities pop out of stack and destroy. Now, previously activity will resume. For example, when you send SMS, you open the messengers and send message. Assume this be your current activity and when you press back key, it should resume the previous activity, right? Previous activity was your own home screen. If you are novice or don't have computer background, you might be thinking, what the heck is this stack and push and pop kind of things? A stack is a data structure in which computer organizes its data in the memory. Adding an atom to this is called push operation and deleting an atom is called pop. And stack has a structure like a book shelf where you arrange your books, but unlike a bookshelf, only one atom can be inserted and deleted from stack respectively. Then layouts. A layout defines the structure for a user interface in your app, such as in an activity. A layout defines the structure for user interface in your app, such an activity. All elements in the layout are built using a hierarchy of view and a view group objects. A view usually draws something the user can see and interact with, and whereas the view group is an invisible container that defines the layout structure for view and other view groups. This is shown in the figure. And this figure gives view hierarchy which defines a UI layout. The view objects are usually called widgets and can be one of many subclasses such as a button, text view, and the view group objects are usually called layouts can be one of many types that provide a different layout structure such as a linear layout or a constraint layout. You can declare a layout in a two-way. First one is a declare UI elements in XML and instantiate layout elements at a runtime. In a declare UI elements, In XML, Android provides a straightforward XML vocabulary that corresponds to the view classes and subclasses such as those for widgets and the layouts. And second one is the instantiate layout elements at a runtime. Your app can create view and view group object and manipulate their properties. Types of layout: Android linear layout, Android relative layout, Android constant layout, Android frame layout, and Android table layout. Android linear layout is a view group subclass used to provide child view elements one by one, either in a particular direction, either horizontally or vertically based on the orientation property. Then the relative layout. Relative layout is a view group subclass used to specify the position of child view elements relative to each other, like A to the right of B, or relative to the parent, means the fixed to the top of parent. Then the constraint layout is a view group subclass used to specify the position of a layout constraint for every child view relative to other views present, and constraint layout is similar to relative layout but having more power. Then the frame layout is a view group subclass used to specify the position of view elements it contains on the top of each other to display only single view inside the frame layout. And the last one is the table layout is a view group subclasses used to display the child view elements in rows and columns. Next component is configuration change. Some device configuration can change during runtime, such as screen orientation, keyboard availability, and when the user enables multi-window mode. When such a change occurs, Android restart the running activity on destroy is called followed by on create. The restart behavior is designed to help your application adapt to the new configuration by automatically reloading your application with alternative resources that the new device configuration. To properly handle a restart, it is the important that your activity restore its previous state. You can use a combination of on save instance state, view model, objects, and persistent storage to save and restore the UI state of your activity across configuration changes. Then next one is the context. The context in Android is actually the context of what we are talking about and where we are currently present. Few important points related with the context. It is the context of the current state of the application. It can be used to get information regarding the activity and application. It can be used to get access to resources, databases, and share preferences and etc. Both the activity and application classes extend the context class. Wrong use of context can easily lead to memory leaks in Android application. As there are different types of context in Android, we as an Android developer often get confused about which context to use as which place. So let's understand what are those and how to use those and when to use which one. There are mainly two types of context: application context and the activity context. Application context is the application and we are present in application, and the activity context is the activity and we are present in a activity. Then the last topic is Android activity lifecycle. An activity represents a single screen with a user interface just like window or frame of Java And Android activity is a subclass of context theme wrapper class. This is the hierarchy of the activity class. There is the topmost class in this hierarchy is the object, then context class, then context wrapper class and the context theme wrapper class. And the activity class is a subclass of the context theme wrapper class. If you have worked with C, CPP or Java programming language, then you must have seen that your program starts from main function. Very similar way, Android system initializes its program with an activity starting with the call on create callback. There is a sequence of callback methods that start up an activity and a sequence of callback methods that tear down an activity as shown in the activity lifecycle diagram. The activity class defines the following callbacks, that is the events. You don't need to implement all the callbacks methods. However, it's important that you understand each one and implement those that ensure your app behaves the way users expect. There are some methods of the Android activity lifecycle. First one is onCreate, called when activity is first created. OnStart, it called activity becoming visible to the user. Then onResume, this is called when the user start interacting with the application. Then onPause, the paused activity does not receive user input and cannot execute any code. And call when the current activity is being paused and the previous activity is being resumed. Then the onStop, this callback is called when the activity is no longer visible. Then on restart, this callback is called when the activity restart after stopping it. And last one is the on destroy. This callback is called before the activity is destroyed by the system. Means activity is stop and prior to start. This is the diagram of the Android activity and the service lifecycle. In this diagram, there are some states. Means here the activity is initialized. After that activity means your application is running. And here this app process will kill. And last one is the activity shutdown. Means your activity will terminate normally. In this state, in between, there are these some methods which is important in a Android activity lifecycle. Then the first one is the onCreate method. It takes one parameter that is either null or some state information previously saved by the onSave instance state method. After that onStart, this indicates the activity is about to display to the user. Then the onResume, this is called when your activity can start interacting with the user, and this is good place to start animation and the music. After that on a pause. On pause, this runs when activity is about to go into the background, usually because another activity has been launched in front of it. This is where you should save your program persistent state such as a database record being edited. Then on stop, this is called when your activity is no longer visible to the user and it won't be needed for a while if memory is tight. Then after it will call on restart. If this method is called, it indicates your activity is being redisplayed to the user from a stop state. And then on destroy, this is called right before your activity is destroyed. If memory is tight, on destroy may never be called. The system may simply terminate your process. Then some method related with the Android activity lifecycle. Save on save instance state. This is a bundle method. Android will call this method to allow the activity to save instance state such as a cursor position within a text field. Usually you won't need to override it because the default implementation saves the state for all your user interface control automatically. And last one is the on restore instance state. This is a call when the activity is being reinitialized from a state previously saved by the on save instance state method. Thank you.